Hi there, my name is Chanel. I will be going over um, questions 3, 4, and 5 for you today. So let's jump right into it. We're going to go over 3 really quickly. This is the question. A superstore has various items in stock from domestic and foreign companies. They gave us a chart here, and they had 455 total items. That was another value that they gave us. They asked us to find the probability of one item being non-domestic. So the other thing is if an item is selected at random, find probability that the product is domestic and a snack. The other part C is one item at random, non-domestic or a drink. D is one item at random, domestic and a cleaning product. So let's jump over to 3. I'm going to zoom in if I can. Oh, that wasn't what I meant to do, so we're going to just let that fade away. Okay, let's go down here. Okay, so starting with our number or our letter A, we're finding the probability of an expected value, an event, or I think it's an event. So first thing we're gonna do is we're gonna enter, it's pretty simple, it's pretty straightforward. We're gonna add up the items that are non-domestic. So over here, our foreign items we see are 192. Oh, I did not, sorry. So 192, that's where we added all that right there up, and we got 192. So then we're going to put 192 over our total products, and we know from our Word document that it's 455. So simple enough, we're going to do 192 over 455, and that gets us about 42.1%. Now we're going to go to part B of this, which is that probability is A plus B. This one is also pretty straightforward, I would say, because they're still asking for one item. This item can be domestic and a snack. So because the word and is used, we're going to focus on what our values of A and B are going to be. So, okay, and then so for part B, it's very straightforward because it asks for what is domestic and a snack. That word and is going to help us to eliminate all of the other categories. So we're going to go straight to the domestic category, and then we're going to go to snacks. That number is 96. Okay, so we're going to do 96 over 455. That's a pretty simple calculation at 21%. Okay, so we're back over here, and now we're going to do part C, which is looking for one item at random, non-domestic, or a drink. So because of the language in this one, it's going to be non-domestic or a drink. So that is going to be the probability of A plus the probability of B. So non-domestic, we had 192, and or a drink. And so we could add our drinks together from both categories, 82 plus 60, and that got us 142. So that is part C, and then we over here, right here, we did 192 plus 142 over the total, which is 455, and we got 334 over 455, which I think I entered wrong a couple times, and we got 60.2% for C. And then for D, Okay, and so now we're gonna go to D. For D, we want one item at random that's domestic and a cleaning product. Because of the language in this, it says domestic and a cleaning product. We know that we're going to need the domestic cleaning products. And to do that, we had 85 cleaning supplies that were domestic, like we learned on our chart back here. We'll look. Domestic is this category, and cleaning supplies, so we had that number there. I can't really see it because it's a little zoomed out. I'm pretty sure it's 85 over 455. And that is our product. And that's how we were able to find our probability for that. Now, I'm going to go to number 4, question number 4, and this one got me pretty good, I'll be honest. It took me a few days to figure this one out, mostly because I think I just had some walls up around it. But we're going to go ahead and start with the data. So we had 16 full-time workers, 10 part-time workers, and 5 were going to be chosen at random. So for this problem, we need to know the odds for everything, the odds for the 3 full-time workers, and the odds for the 2 part-time workers. So for this, we needed to use factorials and the, combination formula. And so that formula is NC times R equals to N factorial over R factorial times N minus R factorial. So for part A, which I'm seeing, I guess I wrote B. So for the first, we want to find the full-time odds of getting the full-timers odds of getting that position. So we had 16 full-time workers and 3 available 3 full-time slots. So only these 16 full-time people could fit in only these 3 full-time spots. And that's out of the 5 available spots. So to do this, we went down here and we did the factorial of this. So 16 times 15 times 14 times 13, and then we did it again over here. We canceled the 13 out. Those two canceled each other out, so that's where it would stop. And that is how we were able to get that 560. If you see here, we break that down again. Now we do the math. 16 times 15 times 14, that equals 3,360. 3 times 2 times 1, that equals 6. We divide it. That gets us our number for 560. For the next part, we have to find the odds for the 2 part-time workers, and they have, or for the 10 part-time workers who have, there's only 2 slots available for part-time workers, right? So we are going to do the same thing as we did for this one. We're going to do our factorials down here. So we're going to start with 10 times 9 times 8 times 7. And then because we have to remember the combination binomial that we're doing, we need to go to, we have to remember that we do 10 minus 2, which is 10 minus 2. And so that 8, that's what cancels out there. okay? So then we're going to do the math. 10 times 9 over 2 times 1, that's 90 over 2, that's 45. We can do 560 times 45, and that gets us that 25,200. And that's going to be our top value for our probability binomial calculation we'll be doing down there. So the final thing we need to do is find the odds for everything. This is, once again, we're plugging in the. So we're going to go up to the data again for the odds for everything, right? So that's where we add the 16 and the 10 together and the 5 spots. So that's where we're going to have 26 factorial over 5 factorial, and it cancels out at 21. That 21 is where will the fraction will cancel itself out. So then we're going to do the math again, which is 5 times 4 times 3 times 2 times 1. And then we're going to do 26 times 25 times 24 times 23 times 22. That is going to get us this beautiful number here, 7,893,600 over 120, which we divide and calculate to get our bottom number or denominator. So 65,780 goes on the bottom for our probability calculation, and that's where we're going to find out that 38.3% of of 3 full-time workers and 2 part-time workers will go. That's the probability. For problem 5, we know that the probability is 61% chance of someone buying their product. That helps us know exactly what some of our values are. So for part A, the question is, select 9 people to talk with. What are the probability of making 5 sales? So we're going to use our binomial distribution formula, which is right here. 9 factorial over 5 factorial, because we want to know the odds of 9 people making 5 sales, or making 5 sales from 9 people. That's going to give us the same right here, 987. It's going to cancel out at the 5. So we're going to do 9876 over 4321, and that's going to get us 126 once you break it down. Now that we have some of these values here, we are able to move on to our next calculation, which is our binomial experiment formula for calculating probability. So we're going to let P denote the probability of success, Q denote the probability of failure, N denote the number of trials, and X denote the number of successes. And we know this from Dr. Carrillo's chapter 3.3 binomial distribution notes. And that's also where he shares the probability probability calculation, which we have right here. Right here. Oh, I'm so sorry about that. Anyway, it's right here. And so we're going to begin plugging in our values here. And once we have because we have them written up here, it's going to make it a lot easier to plug everything in and get our answers. I did use some of, like, I got to to get the answer to the powers. I used a calculator, so but that's what our answers are here, and we're going to once again plug all these in here to get our answer. So yeah. Okay, and then so for the last part of 5, I remember I went to the statistics table, and I went to the standard normal distribution table, and that's where I found A is 0.2, or wait, where is it? Hold on a second. 0.2434, I believe. And now we're going to move on to B. And that's where we have the same formula, the binomial experiment formula that we used up here, except we're going to replace x equals 5 with x is less than or equal to 2. And we know that we use the normal approximation to binomial distribution z-score, and that's z is equal to x minus mu over sigma. And mu is equal to n times p, which is the mean of the binomial distribution, and sigma is the square root of n times p times q, and that's the standard deviation of the binomial distribution, which we know from chapter 4.4 of Dr. Carrillo's normal approximation to binomial distribution notes, PDF that he used for us. So that is what we see here. We're going to enter that z-score as we go into the next page. And that's z, like I said, z equals x minus mu over sigma. And then we have, because we have, we know what mu and sigma are equal to, and we have those values with x is less than or equal to 2, n equals 9, p equals 0.61, q equals 0.39. The one thing we did need to do was solve for x is less than or equal to 2. And so we had to do, like I said, I went to 4.4 of the PDF where we found that with the less than or equal to component, it is add 0.5 to that. So that gave us the value of 2.5 instead of x is less than or equal to 2. That gave us the clearer 2.5 minus 5.49 over 1.46. We do that math and then we get negative 2.05, and that is when I went to the statistics table, actually not earlier. And so when I did the negative 2.05, I was able to get the 0.2018 by going to the standard normal